Hello viewers, I welcome you all to your own channel numbers.The Educator. After a long time I am going to upload the videos. So today I am going to teach a very important question in class 10 from the chapter real numbers, that how to prove that root 2, root 3 or root 7 they are all irrational. Generally this question I have seen every year, it comes in board exam. So this question is very important. So without wasting time, let's start the video. So today we have taken the question, prove that root 3 is irrational. So to prove that root 3 is irrational, first we have to consider that root 3 is rational, and this method is said to be method of contradiction. So as you have seen, we have taken root 3 be rational. So all of you know that every rational number can be expressed in P by Q form. So we have considered root 3 is equal to P by Q, where P and Q are co-primes and Q is not equal to 0, right? Co-prime meaning is what? Where P and Q have no common factor other than 1, right? So after this line, what we'll do, we'll cross multiply. So this will become root 3Q is equal to P. I think all of you have understood. Then now squaring both the side. So root 3Q whole square is equal to P square. Now root 3Q whole square will be equal to 3Q square equal to P square. Right. Now after this line we can write P square is divisible by 3. Now if P square is divisible by 3, we can write P is also divisible by 3. I think all of you have understood. This one you mark as number 1. As you have written that P is divisible by 3, so 3 is a factor of P. So we have taken again that P is equal to thrice R. R is some other natural number. Okay. Now, so if we square both the side, P square is equal to thrice R whole square, which is equal to P square equal to 9R square. Now, if we observe this, here we are getting P square is equal to thrice Q square. Then this value of P square from here, we are going to substitute here. Okay. So in place of P square, we will write now 3Q square, which is equal to 9R square. Now Q square will be equal to 9 by 3 is 3R square. So what we have noticed here, Q square equal to 3R square means 3 is a factor of Q square, or we can write like this, Q square is divisible by 3. We can write Q square is divisible by 3. So therefore Q is also divisible by 3. This one we can mark as number 2. So in number 1 we have seen that P is divisible by 3, and in number 2 we have seen that Q is divisible by 3. That means from 1 and 2 we can write P and Q have common factor 3, right? Which contradicts the fact that P and Q are co-primes. In the beginning I told you, if P and Q are co-primes, this means that P and Q have no common factor other than 1, right? But we are getting that P and Q have common factor 3. And this is happening because of our wrong assumption. In the beginning we assumed that root 3 is rational, but actually root 3 is irrational. Therefore we have to write square root of 3 is irrational, and this is how we have to prove, and this method is said to be method of contradiction, as I told you in the beginning. I hope all of you have understood. Same way you can prove the other questions also. Suppose you are asked to prove root 2, root 5, root 7. They are all irrational. Okay. That's all for today. Thank you.